I think this is the most practical piece of AI policy we've seen all year.
I think it's the most powerful press release.
I'm Milo.
I'm Mila.
And this is AI Daily.
In today's episode, the White House steps in with new rules for frontier AI models, but the key word is voluntary.
Anthropic publishes a report on how it's using AI to build the next generation of AI, and the productivity numbers are steep. And later, we'll explain why a game of Battleship might be one of the most important AI experiments happening right now.
Let's start with the White House. On Tuesday, a new executive order was signed titled Promoting Advanced Artificial Intelligence Innovation and Security. It establishes a new framework for how the U.S. government will interact with frontier AI developers.
The core of the order is a voluntary program. It asks companies developing what it calls covered frontier models to give the government a 30-day window to review their most powerful systems before a public release. It also sets up a new AI cybersecurity clearinghouse to share information about vulnerabilities.
This is the most significant federal AI policy action since the previous administration's order in 2023, most of which was rescinded last year. That order used the Defense Production Act to require companies to report on their model development. This new order explicitly avoids any mandatory licensing or permits, instead opting for an opt-in partnership.
And that's the key distinction. The administration is making a clear choice for collaboration over regulation. The idea is to give agencies like the National Security Agency a look under the hood to develop cybersecurity benchmarks without putting the brakes on innovation. The original draft of this reportedly asked for a 90-day review period, which was negotiated down to 30 after industry feedback.
Which brings us back to my press release comment. A voluntary framework relies entirely on the goodwill of companies in one of the most competitive technology races in history. It sets a tone, but the open question is what happens when a company with a powerful new model decides not to volunteer?
I read that differently. By making it a trusted partnership, you encourage more open communication than you would with a rigid compliance framework. You get more flies with honey. The goal isn't to stop development, it's to make sure the government's own cyber defenses can keep pace with the tools being built.
The order also directs the Attorney General to prioritize enforcement against criminals who use AI to illegally access computer systems. So it has some teeth, just not for the developers themselves.
For now, this framework clearly establishes a federal interest in pre-deployment evaluation. The nature of that interest could change.
Speaking of the companies building those frontier models, our second story is about the feedback loop that's starting to form.
Anthropic published a post yesterday titled When AI Builds Itself. It details how they are increasingly using their own AI systems to accelerate the development of new AI systems. They call it recursive self-improvement.
A term that gets a lot of attention. What does it mean in practice?
It means delegating more of the engineering workflow to AI agents. Humans have the ideas, but the models are implementing, testing, and evaluating them much faster. They shared a striking internal metric. From 2021 to 2025, their engineers shipped a certain amount of code. Today, they ship, on average, 8 times as much.
8 times. And they're clear this isn't because they're rewarding engineers for lines of code, but because AI tools are fundamentally increasing output.
Exactly. And a poll of their own researchers found the median employee estimated they produce around 4 times as much with their internal AI tools as they would have without them. I ran the numbers on that productivity claim 3 times this morning. The acceleration curve is steeper than I'd modeled.
So if the human engineers are 4 to 8 times more productive, and the AI they're building is also being used to find bugs and propose experiments, the timeline for developing more and more capable systems gets compressed significantly.
That's the core implication. Anthropic says that while their human-written code was better than AI-written code in late 2025, the two are roughly at parity today, and they expect AI-written code to be better within the year. Every proposed change to their codebase is now reviewed by a Claude-powered agent before a human even sees it.
This moves the conversation from a philosophical one about a far-off future to a practical one about what is happening in the labs right now. They're not saying an AI is designing its successor end-to-end, but they are saying the components of that process are being automated, and it's making everything move faster.
And if the big models are getting smarter, faster, the next question is how we make them ask smarter questions.
Which brings us to a new paper from researchers at MIT and Harvard who used a classic board game to test how well AI agents seek out information.
The game was Battleship. It sounds simple, but it's a perfect testbed for what researchers call information seeking in an uncertain environment. You have a huge grid of possibilities, and you need to ask a series of targeted questions, in this case, calling out coordinates, to find a few hidden targets.
The researchers first had humans play a version of the game together, collecting data on how people strategize and ask questions to find the ships efficiently. Then, they had different AI models play the same game.
And the results were surprising.
They found that without any special training, the largest frontier models could beat the average human player, finishing the game in fewer turns. But smaller open-source models struggled. The main problem was that they weren't good at asking useful questions. They'd ask questions that revealed very little new information.
It's like asking, is the ship in the water? You get a yes, but you haven't really narrowed down the search space.
Precisely. So the researchers gave the AI models a better strategy. They used a technique called Monte Carlo inference, which helps the model carefully weigh the likelihood of different options being correct with each turn. It essentially teaches the agent how to ask the most informative question possible at every step.
And the result was that with this better strategy, a much smaller, more efficient AI model was able to outperform the giant frontier models and do it at just 1% of the cost.
This points to a fascinating possibility. The key to better AI agents might not always be building bigger and bigger models, but in teaching them better strategies for reasoning and inquiry. It's not about the size of the brain, but how you use it to explore the world.
It's a compelling case that the bottleneck for AI isn't just raw intelligence, but the pragmatic reasoning needed to make the most of what it knows.
Also in AI today, OpenAI announced it is beginning to roll out its improved memory system, which it calls Dreaming, to free ChatGPT users. The feature helps the chatbot remember preferences and context across conversations.
And Meta reportedly patched a security flaw after hackers discovered they could trick the company's AI-powered support bot into giving them access to high-profile Instagram accounts, including Barack Obama's former White House account.
The CEOs of OpenAI, Anthropic, Google DeepMind, and Meta AI all signed an open letter alongside scientists and policy experts calling for legislation to screen and track orders for synthetic DNA to prevent the misuse of AI in developing bioweapons.
And finally, researchers at the National Institute of Standards and Technology have developed an AI model called SafeStep, designed to identify the safest evacuation route during a fire, which could one day power dynamic emergency exit signs.
So a new government framework for watching the models as the models get better at building themselves.
We're building the tools that are building the tools.
And the instruction manuals are being written in real time.